Hello, everyone. Welcome to another episode of the Engineering Student Experience Podcast. I'm Paul Nissenson from the Mechanical Engineering Department at Cal Poly Pomona. The world is full of complex systems and complex processes. Many of you right now are listening to my voice through a phone, and that phone consists of many parts. It contains integrated circuits, a display panel, sensors, a battery, a processor, speakers, and many other parts all held together by plastic and metal. The phone was assembled in a factory somewhere, perhaps in a country halfway around the world. And the parts inside the phone were manufactured from even smaller parts and raw materials in other factories around the world. It takes a tremendous amount of coordination to ensure each link in the supply chain is reliable enough to produce phones at a consistent rate with little or no downtime in the factory. Most of the items that surround you at this very moment are the end product of many processes that involve complex supply chains. And the supply chains for different products are often interconnected as well. The metal screws that were used in one phone also might be used in another phone, or in a completely different device. Multiple companies may create those screws, and it is in those companies' self-interest for all of their operations to run as efficiently and as cheaply as possible. The people who are responsible for the logistics and optimization of complex systems and processes are industrial engineers, which is the topic of today's episode. Industrial engineering is a discipline that's focused on improving the productivity, the efficiency, and the reliability of complex systems and processes while still ensuring operations are safe and sustainable. You can find industrial engineers wherever complex systems and processes exist, which is every sector of the economy. Joining me today to discuss the field of industrial engineering are two faculty members from the Industrial and Manufacturing Engineering Department here at Cal Poly Pomona. My first guest is Dr. Shokoufeh Mirzaei, who is a professor and chair of the department. She specializes in applied optimization and artificial intelligence, and she also was a guest in episode 35 where she discussed what it's like to be a department chair. My second guest is Dr. Payam Parsa, who is an associate professor specializing in supply chains and logistics. During the conversation, Shokoufeh and Payam described the differences between industrial engineering and other engineering disciplines like mechanical engineering, civil engineering, and so on. They also discussed the types of courses industrial engineering students take, the types of jobs available for industrial engineers in both industry and government, as well as the importance of getting advanced degrees and certifications. And finally, Shokoufeh and Payam provide suggestions for students on how they can put themselves in a good position to succeed in their engineering career. When I think about industrial engineers, I'm reminded of a classic essay titled I, Pencil by Leonard Read, which was first published way back in 1958. In that essay, which I'll put a link to in the show notes, Read discusses the enormous effort that goes into creating a simple lead pencil. It requires people who are experts at mining and processing graphite, which makes up the lead in a lead pencil. It requires experts at harvesting trees and processing the wood into the familiar pencil shape. It requires experts at creating and applying lacquer and resins to the outside of the pencil. It requires experts at creating the rubber-like eraser, as well as experts at creating the thin piece of metal that keeps the eraser in place. And I could go on, but you get the point. iPencil was originally written to help people realize the power of free market economics, but it also highlights just how complex our society has become. Even something as simple as a lead pencil is the end product of many, many individual people and individual processes, and each item, each process in that pencil supply chain has the potential to be made more efficient by industrial engineers. So now let's go to my interview with Shokoufeh Mirzaei and Payam Parsa. I hope you enjoy the conversation. All right, well, I'm sitting across the table from two faculty members in the Industrial and Manufacturing Engineering Department today. We have Shokoufeh Mirzaei, who is the chair of the entire department, and we also have Payam Parsa. Welcome to the podcast.
Thank you for inviting us.
Thank you for having us. I'm glad to be here.
So today we're going to talk all about the wonderful world of industrial engineering. Before we do that, though, I think it's important that we have the listener get an idea of who you are. So if you could provide a little bit of background information that's relevant to this topic. So maybe something about your educational background, how many years have you been teaching, if you have any relevant industry experience, stuff like that.
Sure, I'll go ahead. So I got my bachelor's and master's degree in industrial and systems engineering, and my PhD was in industrial engineering with a minor in statistics. I've been teaching now for about 13 years. Amazing how time flies. And before I joined to the academic world as a professor, I worked in industry as a management consultant and worked with major clients such as Caterpillar to help them with process improvement and streamlining their processes. Prior to that, after my bachelor's and during the process of getting my master's degree, I also worked in consulting industry, but it was mostly geared toward construction of big oil and gas power plants and areas that is mostly for energy production and management.
And myself is pretty similar. All my degrees from bachelor to master's to PhD are all industrial engineering. And I got my PhD from University of Arkansas here in 2017. Then I joined Cal Poly here, and I've been teaching for the past 7 years. And it's been a pleasure here, and my area of focus within industrial engineering is mostly on supply chain and logistics, where I worked on projects during my PhD with companies, especially Medtronic, Walmart, on transportation and logistics projects. And then since I joined here, I've been teaching and doing some research and continuing some projects with Medtronic for a couple of years. And here I am.
So if you had to, in just a few sentences, describe the entire field of industrial engineering, how would you do that?
Yeah, well, I think industrial engineering is a branch within engineering that is focused on complex systems. And those systems can be manufacturing systems, service systems, and it improves productivity, efficiency, reduce the cost, improves the quality, and make sure that the customer's perspective also included in delivering the results. So I would say it's an area between engineering and business.
Yeah, and I would add, people sometimes say industrial engineers wants to make products faster, cheaper, and better. When I say cheaper, I want to, take it with a grain of salt. What we mean is maintaining quality while reducing the cost of the production, which eventually results to better product with lower price point for the customers. So a lot of the industrial engineering focus is around different aspects of quality, and quality in our definition means reduction in variability. So a lot of our focus is how we can reduce variability in processes and improve them. As Payam mentioned, it can be a manufacturing process, but also it can be a service process. Like for example, it could be a customer call center. It could be Disneyland. You're looking at processes and try to reduce waste to improve user experience sometimes, or provide a product that is better. So it can mean different things in different contexts, but we are always trying to improve quality within the organization.
So in addition to improving quality, efficiency, all of the things you mentioned, how much also are you focused on improving, let's say, safety?
It's actually, it's interesting that you mentioned, and I think it could be related to the sub-discipline within IE. In some places, actually safety is a branch or sub-discipline within IE, but I haven't seen that necessarily within the US. But in overseas, you would see safety as a sub-discipline within IE. So definitely safety, and especially OSHA standards. There are standards and specification, which is work and occupation hazards and safety. These are things that you have to include in your design and into your recommendation and processes. So definitely safety is high on the priority when you think about any improvement or quality aspect.
Yeah, I think as Shokoufeh mentioned, safety is within the human factor part of industrial engineering, because industrial engineering has a subdiscipline called human factor and ergonomics. And I think safety is within that subdiscipline, where basically any design and any systems that we're improving, we are considering the human interaction and human factor within that process improvement. So yeah, big part.
So you guys mentioned subdisciplines. So how do you break down the entire field of industrial engineering into different subdisciplines? And what kind of courses do students take if they're getting an undergraduate degree in industrial engineering? What kind of courses do students take in those subdisciplines?
So I cover some of the subdiscipline, and I let Payam cover some that is more in his realm. So there is a whole decision-making process, data-driven decision-making, and is one of the biggest area in industrial engineering. That's why we cover operations research or optimization, which is one of the courses that is core for any industrial engineering. And sometimes you see there operations research 1 and 2 course around optimization. And usually data analytics is also as a part of it, because data-driven decision-making and optimization is one of the foundational knowledge an industrial engineer should know. And what does that mean, and what's called operations research? Because it came out of the World War II, where there was the scarcity of amenities and human resource to accomplish missions and be successful in them overseas. So the U.S. Military compound actually hired a bunch of scientists and mathematicians to come up with the best way of allocating limited resources to optimize or minimize the cost of these operations and maximize the outcome from them. From that, the whole field of operations research came out, because operation at that context was called military operation research. And now we call it optimization mostly, but the name operations research comes from that background and history behind it. But optimization is basically, the definition is trying to optimize the outcome of this desired outcome of a system given a set of constraints. Now, it could be human resource, budget, the setting of a machine, the number of workers you can have in a given day. So you're trying to maximize the output given those constraints that you have. And we teach our students how to formulate that mathematically and provide tangible outcome. So that's one of the subdiscipline which is very strong, and student can follow to their master's or PhD, kind of like I did, and my area was optimization and data-driven decision making. You have decision analysis and all that comes into the place, like what happens under uncertain situations. So that's one big area in industrial engineering. But there are other areas, supply chain, facility planning, and process improvement, that I will let Payam to chime on that.
Yeah, I think the good thing about industrial engineering is you learn about a bunch of different tools and techniques that you can apply in almost any industry. And operations research and optimization that Shokoufeh is talking about is something that can be applied in hardcore manufacturing problems, as well as aviation problems, as well as healthcare systems. There's always a potential for optimizing the system, and that system can be anything. But besides that area, I think in industrial engineering, you have quality and reliability engineering, where you basically collect data from the system and you statistically analyze the system to improve its quality output. You have supply chain and logistics, where you do supply chain management in making sure you have inventory in the system, make sure the transportation is being done on time and delivery is being done on time. Then you have human factors and ergonomic, where you design a human-centered system, and safety is also part of that, as we mentioned. And also we have the manufacturing and production systems too, where you learn about manufacturing processes. You deal with robotics, how to automate the manufacturing processes, and also facility planning, how to design the facility to make sure that the manufacturing is being done in an optimized way.
And because our major is very diverse, we don't have like professional engineering exam like other majors like civil or ME might have. Our students can get certified in a specific subdiscipline and grow in that area. For example, if you're interested to go become a quality engineer, then you go get your Six Sigma green belt or black belt, and you build your basically experience toward that direction. Now, if you want to go in supply chain direction, then you go get supply chain professional certification and build your experience into that direction, because it's a very, like Payam mentioned, you have a toolbox that allows you to do so many things, and now you have to choose in what area you really want to build your experience and get your specific certification in that area.
You both have mentioned statistics a lot. So compared to, say, a mechanical engineering student or civil engineering student, do people who are or students in industrial engineering have to take a lot more statistics classes?
Yes. So in some universities, statistics and probability are most universities, I would say there are two separate courses. You take a course in probability and you take a course in statistics. So usually you end up being in a program that has two statistical probability courses. In our program, we used to be that way, but recently we have combined them, but it's a bigger course, so a bigger number of unit. But we are also going back to adding a lab component to allow more exposure to statistics, because it's embedded in every other course that students need to go to.
Yeah, I want to add to that the reason that probability and statistics are very important in industrial engineering, and students take more in-depth courses in that area, because the systems that we're trying to optimize, they're all subject to randomness and probabilities. And, so when you deal with optimizing these systems or improving these systems, you're dealing with a lot of uncertainties, and those uncertainties need to be mathematically modeled and deal with in the model. And so that's why understanding of probability distributions and statistical methods are really the underlying fundamental of every other course.
Yeah, like for example, your data analytics course will feed off of your statistical knowledge, because you're going to do a lot of p-value analysis and hypothesis testing. I know some of these terms might not be familiar for someone who's in high school, but let's say if you want to test whether your hypothesis of this system is better than the system that you initially started with, you have to kind of like test that with data. And the only way that you can justify and make sure that your new system is better is looking at that data and test your hypothesis in using a statistical methods. If you look at the simulation course, which allows the students to simulate a system to compare before after, again, all the simulation is built based on the assumption that this system follows a certain behavior in its randomness, which we call a distribution in a statistics. So a lot of the courses that is covered in IE or industrial engineering and feed off of those knowledge in a statistics. And if the students don't have that foundation, then they're going to struggle with being able to communicate their findings with the stakeholders in the future. So it plays a big part in the curriculum.
So here at Cal Poly Pomona, the industrial engineering program is combined with the manufacturing engineering program under one department, which we call the Industrial and Manufacturing Department, of which Shokoufeh is the chair. So why is it, let's say, natural to do something like that? And what are some of the similarities and differences between industrial engineering and manufacturing engineering?
Because industrial and manufacturing engineering both look at process development and improvement, they have that part in common. Like, for example, both of these major heavily rely on a statistical analysis. They have to have a knowledge of manufacturing processes. They have to have a knowledge of human factors when it comes to design. They have to have a knowledge of engineering economics. They have to have a knowledge of engineering ethics. They have to have a knowledge of optimization. So there are so many courses that are in common between them, but at the same time, there are differences because a manufacturing engineer is focused on that manufacturing subdiscipline that IE can decide to get focused on or not, right? So manufacturing, the way that I can make a distinction between manufacturing engineer and every other engineer is that let's say mechanical engineer come up with a really nice prototype of a car. That car is not going to be mass produced tomorrow because it doesn't have manufacturability. So that means you don't have a technology set up, a process set up to mass produce this car that is at the prototype stage to be affordable for everybody out in the world to take advantage of this car. So you get courses that specializes in manufacturing technologies and processes and machineries and theories that allows you, when you see a product, then you can think about the process that allows this product to be mass produced. Or sometimes, usually, you want this process to be complex enough for a manufacturing engineer. If you're making a pen, maybe you don't necessarily need a manufacturing engineer, but you need it when you're dealing with a very complex system like a car, an airplane, where you need to really set up the process that involves with the assembly and manufacturing. So there are common courses in knowledge between the two fields, but at the same time, there is areas that manufacturing engineer focus on that an IE might not be necessarily needed or necessarily focused on.
Yeah, I agree with that. And I think one of the reasons that manufacturing engineering and industrial engineering are a lot of times seen together in one department is because originally all the tools and techniques in industrial engineering started being used in manufacturing problems. And then later on, with technology and with big data and all of that, a lot of those techniques now are being used in service settings. So manufacturing setting was the original application of a lot of these tools, and I think that's why they're been together a lot, in many different departments.
I think that's a great point, Payam, because if you look at where, for example, lean manufacturing started, it was in Toyota assembly line and, all those work that really bring a lot of these contexts into life for industrial engineering. It was even in manufacturing setup. So definitely that. But I come from, I got my PhD from Wichita State University, where manufacturing engineering was a part of the mechanical engineering. And so it's not necessarily needed that the two should be combined together. Sometimes you see manufacturing as a part of mechanical engineering, and somehow is kind of depends on how the program is set up. Manufacturing also has a lot in common with mechanical engineering. At some point, though, they go to different directions. So they might have some of the similar foundational knowledge in statics and thermodynamics and things as such. But then at some point, manufacturing engineer more focus on quantity of scale and how you can scale up a design to mass production. But mechanical engineer might be more focused on how bring an idea into realization and prototyping and a working model. So that's where the divergence, I think, happens for mechanical engineering and manufacturing engineering. But you might see either manufacturing as a part of industrial engineering, they two be a package in one department, or sometimes you see manufacturing with mechanical, and that's what it comes down to.
So as you mentioned, manufacturing engineering is sometimes a specialization within mechanical engineering. Do you ever find cases where industrial engineering is a specialization within a different engineering discipline, or is it usually by itself, like an industrial engineering program?
No, I haven't seen industrial engineering to go under another program necessarily.
If they were to be combined, I think in some other universities, especially outside of US, I've seen sometimes it's being combined with mechanical engineering. Sometimes it's been combined with systems engineering. But when you have bigger enough college of engineering, you would most likely see a separate industrial engineering department.
So for students who get their bachelor's degree in industrial engineering, what are the typical jobs that they get in both private industry and in government?
Very good question. Actually, we have a whole Instagram page around that because we reached out to all our, not all, a group of our alumni and asked them to record 30 seconds videos of where they are, what they do. And I think it would be a good addition for the listeners if you can put that link as a part of this podcast information. But our, students after graduation land jobs in different industry. You can work, in places from Disney all the way to, aerospace and SpaceX or Northrop Grumman if you want to. And one of the beauty of industrial engineering is that you can choose what type of industry you want to work on. So we have graduates that become like supply chain manager in a water bottle manufacturing company or in big companies like Pepsi, Amazon, if you're dropping names, or some people say, I'm interested to work in, auto manufacturing. Then they get a job as a quality engineer, maybe in auto manufacturing in Michigan, or they can get a job in, one of our students after graduation actually went to the East Coast and because he wanted to work for Under Armour. So it's up to you and what area you want to work. Let's say if you're a quality engineer, you can work in Kaiser Permanente, Mattel, make Barbie, go to Disney, improve user experience, or go to aerospace and make, improve processes around manufacturing airplane and rockets and things as such. So it's a very, very, very broad career opportunity.
And also you mentioned government. Industrial engineers I've seen, they get hired in logistics and defense a lot within the government. They become analysts of transportation systems within the, let's say, Defense Logistics Agency. And Lockheed Martin, a lot of the contractors of the government, industrial engineers get hired to be an operational engineer or to be a quality engineer, supply chain manager of those contractors and suppliers of the government.
So I imagine right now, since industrial engineering has a lot of statistics, I imagine AI is just, it's becoming infused in all of engineering. So how is AI being introduced into industrial engineering?
Coming from industry before I became a professor here, I started an elective course around the application of data analytics in industrial engineer, because what I did as a consultant, it was just working with data to improve the processes, crunching data, coming up with decision. And then as a part of that, I included machine learning, some basic models that it's mostly commonly used, clustering, classification, unsupervised and supervised learning, that might be terms that our listener not necessarily familiar with, but methods in machine learning. And then right around the time that we thought, based on the feedback from alumni, to make this course a required course as opposed to elective, the whole AI thing became a major topic of conversation. And then we started rethinking our whole curriculum on how we can incorporate AI, and as opposed to dismissing it, because we know our students are going to use this. Let's acknowledge this and figure out the best way we can incorporate these AI techniques into our curriculum. And obviously, one of the ways was to bringing our data analytics course as a required course, but also looking at about 7 to 8 other courses within our curriculum that can benefit from the introduction of AI techniques. And then we wrote an internal grants for that. We were successfully received grant for 7 of these courses to be modified to incorporate AI. as a part of our holistic view to the curriculum. So we are excited to incorporate these, and a lot of them is to basically acknowledge the existence of AI and introduce AI tools that allow students to use them as they go through their process. But what we are teaching them is to do the method and compare with what the AI would give them and do analytical thinking. Because what happens is if you end up, for example, to work for NASA, you won't have access to these AI tools. And if all your knowledge is to how work with, AI, and you don't have that at your workplace, you're going to be really in disadvantage because you heavily relied on in these AI tools to get every task done. So we want to make students aware of this situation that, this is how you do the work, this is how you cross-check with AI, and how you can analyze if it's done right or wrong. And this is when you have access to these tools, this is how you can, extend your work to the next level, expedite your work to the next level. But we're not going to replace our knowledge with what AI gives us, because when, I had a conversation with few folks from JPL, and they were saying that I cannot use any of these things because we are not allowed to do these things. We are not allowed. These are all, stuff that are sensitive, and we cannot really take advantage of AI. And also, we want to teach our students how to communicate the result that is generated as a result of AI, right? So building trust comes back to statistics. How can you say AI consistently can generate the same result? What are the methods that you can test your result and is reliable? Because people in industry will always have their doubt if it's AI generated, right? So we're bringing flavors of AI into our courses, but we're not removing what the student needs to know. It's kind of like giving a student calculator without teaching them math, right? So you want to first teach them the math and then give them the tool. Is the same idea here as well. Teaching students the topics and give them AI tool that they can then assist them in doing the work, but not replacing it.
Yeah, and also another area that AI has been embedding with our original curriculum is robotics and automation, and it's a very hot area these days, and it has its impact on many different areas within industrial engineering. For example, in supply chain and logistics, a lot of the warehouses, distribution centers are now being run with robots, and those robots, they have AI models that manage them. So what we're feeling in our department is that we need to embed these artificial intelligence and machine learning models with every other course, essentially, because it is the traditional methods that we teach in those other courses are being impacted with the advanced machine learning and AI models, and new tools are emerging. So we need to bring them into every other course. So I think it's going to be a fascinating few years after this to see how we can kind of revolutionize maybe our curriculum based on artificial intelligence and those emerging technologies.
Yeah, and going back to what Shokoufeh was mentioning, I teach a numerical methods course, which is where you have all these complicated mathematical formulas that you convert to computer code to solve some engineering problem. I always say that the programming language that you use, it's kind of like a black box. You can put some stuff in and some stuff comes out, but you have to have the basic skills to determine if, I always call them sanity checks.
Yes.
Just to determine if it's within like a reasonable realm of possibilities. Yeah.
Yes. Like, to give you an example, yesterday I was working on a data set that was given to me from the actual airplane, bunch of sensor data. And I was trying to come up with to add 2 columns to this data set that give me the airplane path. So I used AI. And I was like, can you help me to set up this quickly? Because I didn't want to spend extensive time on just generating the flight path. And then it generated a few, columns and used those as intermediate columns to give me the flight path and X and Y, basically X, Y, Z in the plane where the airplane is. And then I'm looking at this And I was like, wow, this is amazing. It did it very quickly. But when I looked at the equations, all the references to the cell were incorrect. Like, for example, as opposed to using the roll angle in calculation, was calculated a random column in the Excel file. So if I did not have that knowledge, I wouldn't be able to fix the error and do move on with the rest of my calculation. So just working with AI and not being able to cross-check and understand where the mistakes are happening, you end up with completely wrong answers and results. So that's the reason I think it's important to give the students the knowledge to be able to cross-check an AI-generated work. It expedited my work significantly, but have I not been able to read the equations and know what needs to be where, I wouldn't be able to quickly use it toward the rest of my research. So there is definitely advantage. It would take me like 3 hours to do that myself. I did it in maybe 10 minutes, but because I knew what the right equation was and how to place things.
So I want to run through a couple different scenarios here to help the listener get a better idea of what industrial engineers do. So let's go with the first scenario. Let's go back to Toyota, manufacturing a new car. So let's say that right now there are engineers who are working on designing a brand new car. It may be a couple of years before it actually starts getting manufactured and sold. So there, of course, has to be engineers involved with the design of the car and refinement of the design. And at some point, they're actually going to put it at full-scale production. They have to build a facility. They have to select what the assembly line will look like, what machines will be used, and have to be safety. People have to consider human safety, I'm sure, with big machinery like that. And then you have to have the distribution of the vehicles all throughout the, let's say, U.S.
The whole supply chain.
So yes, exactly. So where in all of that process that I've just discussed, where will you find industrial engineers involved?
Everywhere.
Yeah.
That's why we teach them, industrial engineer is an ocean with a depth of an inch. So you learn about every engineering discipline, but you don't get too deep in any of them because you need to know enough to work with a group of engineers. There's areas that you get a specialty like optimization and a statistical and data-driven decision making, but it's all to be able to work in concert with everybody else. And that's why sometimes systems engineering is a part of industrial engineering. We offer systems engineering master's program. So everywhere in this process, you would see, IE involvement from supplier selection to all the way to defining the assembly line, the number of workers, even the schedule of the manufacturing and assembly, material requirement planning, resource planning, whether it's workers or material, should be done in consultation with industrial engineer. And sometimes softwares are there to help, like, for example, ERP tools, and Payam can speak to them. But I would say a lot of these that you mentioned will involve industrial engineer.
Yeah, I think as soon as you have the design, the first thing to make decision on in what are the materials that you will be using, so the manufacturing part of that design. How do we manufacture this? You have to pick what material you got to use that satisfies the specification of that design, and then think about the production workflow of that. You want to mass produce that, so how big the production line needs to be for a certain volume. How many people do we need there? How many machines do we need there? And how fast you want to produce based on that certain speed of production, how many people you need. And then it goes to supply chain and logistics of it, both from the supplier side, all the raw materials that are coming, what are the suppliers that we need to choose, how often do we need to get delivery from them to the manufacturing plant, and then on the outbound side, when your final product is ready, how do you distribute them? How many distributors you need, what locations they need to be at, and then
how many warehouses you need.
How do you operate those warehouses?
What is the layout of your facility for production?
That's right.
Right. So all of that.
So you would be working with, say, civil engineers in the creation of those warehouses and manufacturing plants, and then
It depends a lot of this because, in the past, what we called traditional systems engineering, in the past, the way that it worked, the mechanical engineer came up with a design and gave it to the manufacturing engineer and said, okay, we want to make this, now go figure it out. But now we say that is not right. You have to have concurrent engineering. Why? Because when the design is done and you give it to manufacturing guy and says, oh, you want to manufacture this with this cost, is impossible because the technology that is required for making this this type of bend or metal forming is so expensive that you're not, or it's so slow that you're not going to make that much. So go back to the design and fix it so that you can make that many. And then that process of going back and forth to revise your design for manufacturability would delay the production so long that now they say they have to do concurrent engineering, meaning that a manufacturing engineer should be in the design process along the way to inform the mechanical engineer of the constraints of the manufacturing. Because if you don't realize that you're trying to manufacture this at the end of the day with certain number of production a day that has technological limitation, you will not be able to hit the target. So even though your design is amazing and works in prototype, it doesn't mean that it's gonna, cut it for the manufacturing side. So for that reason, a manufacturing engineer works concurrently, or industrial engineer, in that matter, can have to work concurrently with the design engineer for taking something from the idea all the way to the production. And after production is not only manufacturing, is like supports, right? So after more sales support, that the reliability, like how much you want the system to work. What is the maintainability of this? Are you designing this for people to be able to change the battery or not be able to change the battery? Are you designing this for people to bring to the facility to fix it, or you give them the tools to fix it at home, right? So these are the decisions that needs to be made during the design process, that if the manufacturing engineer or industrial engineer is not a part of this conversation, it would not be decided, and a lot of back and forth and redoing in the design would happen. If you're designing for a warranty of 1 year, that means you have to design your product that doesn't fail with 99% within the first year. And sometimes you're happy to get warranty, but it's designed to not fail during the warranty time, not to deter people from buying a warranty, but it's by design that way. So these are the important conversation. And I think once that if that conversation happens early on, a part of these feedback is already included. And when it comes to designing the assembly line and manufacturing process, it's going to be much smoother. And, based on the number of unit that you have to make on a daily basis, everything goes backward and you can design the line that is able to meet the target production a day. Sometimes it could be in terms of units a day. Sometimes it's hundreds of thousands of units a day, like semiconductors that you're trying to make, like millions of the unit per day.
So I have another example that I like using about bringing a new potato chip from Frito-Lay to full-scale production. But it sounds like everything that we discussed with vehicles from Toyota would also apply to potato chips from Frito-Lay.
Yes, everything is pretty much the same.
How important is professional licensure for industrial engineers? So that would involve, taking your FE exam usually near the end of your bachelor time as an undergraduate student, and maybe taking your PE license later on as after you get some industrial experience. Or as you were mentioning earlier, Shokoufeh, is it more certification that's important in industrial engineering?
FE exam and PE exams for industrial engineers are not as important as for the other engineering majors. And as Shokoufeh mentioned, because industrial engineering is so broad with so many different fields, each field has its own certifications. So in quality engineering, we're talking about Six Sigma, green belt and black belt. In supply chain and logistics, we're talking about 2 organizations that certify them, One is Association of Supply Chain Managers, and the other one is CSCMP, which is standing for something similar to that. So different different certifications from different areas for industrial and manufacturing engineers. So less importance on FE exam, I would say.
Yeah, I agree. And as I mentioned earlier, depending on what area you want to get your foot in the door, you'll seek certification that are accepted by industry. Like, for example, if you want to go to automation, maybe you consider SOCA certification around automation. If you want to go to supply chain, you seek like other certifications. So we don't have one fit all like FE kind of exam that you can take and get professional licensing. It's sub-discipline oriented.
How important is graduate school for industrial engineering majors? How can getting like a master's or a PhD, like what kind of doors does that open?
I just want to give a quantitative example of the importance of the master's degree in your paycheck. I was just checking this morning. There is a website called Cal State Pays, which basically publishes data from alumni of CSU campuses in different majors. And I was comparing for industrial engineer, 5 years after graduation, it's about $82K for undergrad, and it's $128K for master's. So about $50K difference. And if you look at it across the engineering discipline, i.e. master's pays the most out of any other engineering. So if you look at ME masters or civil engineering or any other major, I made a comparison, and students who gain their master's degree in industrial engineering, then they get paid the most across, at least within the limitation of this data that was provided by the CSU. But it's very eye-opening. So in terms of how much it's important, makes a huge difference in your paycheck, I have to say. But also we are getting to an era where everything now becoming more complex, AI-oriented, automation. So I personally encourage everybody to go pursue master's degree, because you would never look back and regret getting an additional degree and extra knowledge. It definitely is a boost for you professionally and personally. So I would highly encourage anyone after their undergrad to consider master's, especially for two reasons. First is only 2 years. The first year is your first year. The second year is your last year. Before you know it, it ends. Second, it gives you a huge advantage for landing jobs that are higher in pay scale. And also, we're going toward an area that the more knowledge you have, probably you're better off for generations to come.
Yeah, I think it expands your career opportunities and also allows you to specialize in one of the areas that you really like the most during your undergrad, and becomes more of a specialist in that area. And with the master's degree, definitely companies give you more credibility, because you were able to take it to the next level and exercise your critical thinking even at the most basic level. And then all the way to the PhD level, PhD opens up essentially two different pathways for you. You can become an academic like myself, become a faculty member at a university, or you can take those advanced knowledge that you have, especially these days with industrial engineering, especially in the area of operations research. A PhD degree is very much worth it, even master's degree very much worth it, because the area of operations research has been mixed with data analytics and AI that needs graduate knowledge. And it opens very good opportunities in terms of your job opportunities and the base salary that you start with. So it really depends on which area within those subdisciplines of industrial engineering you want to get a graduate degree on. But you can always also get a graduate degree of industrial engineering with some sort of a specialization area.
Well, to get into a master's program, often you need to have at least, a certain level or a certain GPA, right? So during students' undergraduate years, what recommendations do you usually give to industrial engineering students to not only get good grades, but also to put themselves in a good position to be hired immediately after getting that degree?
I would say definitely consider doing internship. Besides obviously having a good GPA, we usually require 3.0 for majority of the master's program across the nation. 3.0 is the standard. So obviously get a good GPA and then take advantage of internship. For me, it was very eye-opening. I was able to get into different industry to get a flavor of them and understand which one suits me the most, because you can get your foot in any industry as an industrial engineer. You can work in a manufacturing setup, or you can work as a consultant, or you can work in Disney, right? So service industry. So internship is the great opportunity. You get a quick understanding of a type of job that might suit you well. And if you don't like it, you're not having a full-time commitment to it. You can get out of it by the end of your internship. But at the same time, it can open doors for you in a specific industry if you want to do that. So a good GPA, definitely internship.
Yeah, and in addition to that, because internship is very important, academic standing, internship gives you the, real world experience. Also, I would add some of the extracurricular activities on the campus, such as getting involved with societies and clubs, and exercise and learn more on the leadership side of your skills, on the soft skills that you need to develop during your college years. Also, networking events the university has to grow your network during the undergraduate years. And combination of all four, of good academic standing, internship, societies and clubs for your leadership and teamwork skills, and networking, I think it sets you at a very at a good position to get a very good job, or get admitted to a very good graduate program.
So earlier we discussed AI. Are there any other emerging areas that are important in industrial engineering, and anything else that's in the future of industrial engineering that you see?
Yeah, I think emerging areas within industrial engineering, you can see areas related to sustainability and green systems engineering, where we're focusing now on doing the traditional things that industrial engineers do, but now in a more green and sustainable way. And that's become a major area of focus. Also, as I mentioned before, advanced robotics and automation. That's another area that has a lot of potential. Industrial engineering are getting involved very much. Healthcare systems are now even more trusting engineers and industrial engineers to optimize their system and improve the delivery to the patients and their customers.
So Shokoufeh and Payam, thank you so much for taking time out of your busy days to come and share your knowledge of the field of industrial engineering. I got one more question before we go. Imagine you got a room full of high school students, senior level high school students. They're interested in being engineers, but they don't know much about the different fields of engineering. And what would be your 1-minute pitch about why they should consider going into industrial engineering?
Especially because you mentioned that sometimes high school students are not, they don't have a good understanding of what field of engineering they might be interested in. I want to say industrial engineering is the perfect field because as industrial engineers, they can work in every sector. So if they are not sure at the moment what sector they want to work in the future, industrial engineer allows them to get their degree and through that process figure out what sector they really want to land a job in the future. Another reason I would say become an industrial engineer, because it combines technical skills with business skills. So they have an understanding of the technical and engineering aspect, but also develop skills around how to run a successful business, how to make this engineering product that is not only good from a technical standpoint, but also can make good money. And that's why a lot of industrial engineers go up the ladder of corporation very quickly and become managers and leaders in a short span of time. Another reason I want to say follow industrial engineer or become an industrial engineer is because everything in industrial engineering is data driven. So we are in an era where AI and data-driven decision making is critical, and industrial engineering give you the tools that allows you to use AI and other data-driven method to apply in your decision making process. And finally, industrial engineer focuses on processes as opposed to specific part of a technical system. So you're dealing with the system of machines, a system of machines that is combined with human, which makes it unpredictable but also exciting at the same time. So future is bright for industrial engineer. I highly encourage our listeners to consider learning more about industrial engineering. Explore the Instagram page that is going to be in the bottom of this podcast, and reach out to us if you have any question and you want to know more.
Well, I think my pitch is that industrial engineering is the most interdisciplinary engineering field. It combines engineering with business, with human interaction, and it's incredibly versatile because whether you're interested in healthcare, tech, manufacturing, even sports analytics, you will learn some skills that can be applied in all of those fields, because at the end of the day, you are making meaningful improvements that save time, save money, and basically, improve lives of every day and all the customers of these, different sectors.
I think out of all the interviews I've had that are related to a particular subject area, I think this is the first time someone's mentioned that it's the perfect major. So, Shokoufeh, Payam, thanks so much for this conversation. I really had a good time.
Thank you very much.
Thank you very much for having us.
Thanks again to Shokoufeh and Payam for discussing the field of industrial engineering with me. I've placed a few links in the show notes. The first link is to the Industrial and Manufacturing Engineering Department's Instagram page, where you can listen to alumni from that department discuss how the program has prepared them for their engineering career. The second link is to the Industrial and Manufacturing Engineering Department's website, in case you want to learn more about the industrial engineering program here at Cal Poly Pomona. And the final link is to the I Pencil essay by Leonard Reed that I mentioned in the introduction to this episode. Before I go, I'd like to mention that if you're enjoying this podcast, there are a few ways to support it. You can subscribe to the podcast using your favorite podcast apps such as Apple Podcasts, Stitcher, Google Play Music, Spotify, and many others. You can rate the podcast and leave comments on whatever app you use to listen to the podcast. And finally, you can help spread the word about the podcast by telling your friends and family or anyone else that you think might be interested in this podcast. So take care, everyone, and goodbye for now.